Hello guys. So in the last lecture we have studied shafts in series. Okay. Now we'll continue with the next problem. Okay. This is your question. There is a shaft having a drill hole of 16 diameter in the portion of L1, and there is boring is done for a diameter of 24. Okay. The outer diameter of the shaft is 40 mm. Okay. The total length of the shaft is 800 mm. Okay. So this is a given question. So see, determine maximum power transmitted by shaft at 200 rpm if shear stress is not to exceed 70 mpm. Also find the length of the two portions if the twists produced on the shaft are equal. Okay. So we need to calculate the torque transmitted by the shaft. Okay. And by using that we can calculate the maximum power that can be transmitted by using this shaft. Okay. And as angle of twist in the first portion and second portion is same, so by using that we can calculate the lengths also. Okay, let's see. Okay, so the maximum shear stress is not to exceed 70 MPa as it is given. So we can see that in the first portion the central hole is of diameter 16 and in the second portion is of diameter 24. Okay, that means in the second portion the polar moment of inertia will be less as compared to in the first portion, right? So because of that, polar moment of inertia is less in the second portion, so shear stress will be maximum in the second portion only. Okay, so by applying the torsional equation for second portion only, we can calculate the torque transmitted by the shaft. Okay, so maximum shear stress will be in the second portion. So tau max by R2 is equal to T by J. So tau by R is equal to T by J. So tau max by R2 is equal to T2 by J2. Okay. R2 is the outer radius. So torque will be tau by R into J. So shear stress is 70. J pi by 32. 40 raised to 4 minus 24 raised to 4 upon a radius is 20. Outer radius. So by using that, the torque transmitted will be 765.644 into 10 to the power 3 Newton mm. Okay, just do the calculations also in your calc. So as the torque transmitted by the shaft in the second portion and in the first portion will be same. Okay, as it is transferred by the outer portion only. So because of that, the torque will be same. So by using that, we can calculate the power as we know the RPM value. So 2 pi nt mean by 60. So 2 pi n, just put the value of RPM, 200 RPM is given. The torque transmitted that we have calculated 765 divided by 60. So you will get the power in kilowatt. Okay, by multiplying 10 to the power minus 3, by that you will get the power in kilowatt, 16.036 kilowatt. See the unit system. Okay, so the answer will be 16.036 kilowatt. Okay, as it is given in the question, theta 1 is equal to theta 2. Okay, so we'll get first condition as TL by GJ, that is T1 L1 by G1 J1 is equal to T2 L2 by G2 J2. Okay, torque transmitted is same, it will get cancelled. Material is same, because of that G will get cancelled. Okay, only the polar moment of inertia will be different in the first portion and in the second portion. Okay, so L1 by 32 40 raised to 4 minus 16 raised to 4 is equal to L2 by pi by 32 40 raised to 4 minus 24 raised to 4. Okay, it is on side, it is actually wrong. It will be like this. Okay, so and another condition, this is your first condition, and another condition is L1 plus L2. L1 plus L2 is equal to 800. Okay, the total length is 800. So because of that, L1 plus L2 is equal to 800. So you have two equation and two unknown. Okay, so by using calc you can calculate by using two equation, two unknown. So L1 will be 422.549 mm and L2 will be 377.45 mm. Okay, so these are the questions for shafts in series. These are the typical questions, and similar type of question will be asked in your question paper, in your university question paper. Okay, by changing the values. Okay, these are most typical questions, and similar questions will be asked in your question paper. Okay, now we will start with the composite bar or shafts in parallel. Okay, we know that the condition for shafts in parallel is angle of twist is same. Okay, that is theta 1 is equal to theta 2, and the total torque will be distributed in the shafts which are in parallel. Okay, so total torque T is equal to T1 plus T2. Okay, so let's see the questions for composite shaft. Okay, only one question will be feasible or more than enough to solve the different questions in the shafts in parallel or for composite shaft. Okay, composite shaft consists of steel rod 60 mm diameter surrounded by closely fitting tube of brass. Okay, find outside diameter of the tube. When torque of 1000 Newton meter is applied to shaft, it will be sheared equal. Okay, torque will be sheared equal. The modulus of rigidity for steel 8.4 into 10 to the power 4 Newton per mm square. Modulus of rigidity for brass 4.2 into 10 to the power 4 Newton per mm square. Also find maximum shear stress in each material and common angle of twist in a length of 4 meter. Okay, right? Just read it once and write down or chalk down. Okay, the given data, draw a diagram specifying a questions. Okay, so just do it. So what is given? We'll draw a diagram. Okay, this is steel shaft. Okay, inner portion is steel of strip and outer portion is of brass bush. Okay, inside diameter is 60 mm, outside diameter we need to calculate, that is D. Okay, the torque is applied 1000 Newton meter. Okay, and which is shared equally. That means a steel shaft will transfer 500 Newton meter and brass shaft will transfer 500 Newton meter. Okay, material is different. That is material of steel having shear modulus 8.4 into 10 to the power 4 Newton per mm square. For brass 4.2 into 10 to the power 4 Newton per mm square. We need to calculate outside diameter maximum shear stress. Okay, let's see. We need to calculate outside diameter maximum shear stress and common angle of twist. Okay, outside diameter maximum shear stress, common angle of twist. Right? So this is your question. This is your diagram. The torque given, G of steel, G of brass. Okay, diameter we need to calculate, shear stress in both portion of the shaft. Okay, that is steel and brass we need to calculate, and total angle of twist. Okay, as it is given, it is shared equally. That means T1 and T2 will be 500 Newton meter. Okay, equally distributed. By applying condition theta 1 is equal to theta 2, by using that we can calculate a dimension, that is outer diameter. Theta 1 is equal to theta 2, TL by GJ for steel, TL by GJ for brass. It is condition for members in parallel or composite shaft. Okay, as torque is same, length is same, it will get cancelled. G and J are same. G and J, for G and J we can equate it. Okay, J of steel is equal to G of brass, J of brass. Just put the values. Okay, and get the value of diameter. Okay, just do a calculation carefully. You will get diameter 78.964 mm. Do this calculation. Okay. Okay, the value will be 78.964 mm. Next, we need to calculate the shear stress. As we know, as we have the dimensions also, we have the torque transmitted also. So by using torsion relation, we can calculate the shear stresses applied on steel and brass. Okay, for steel, tau by R is equal to T by J. So tau of steel upon R of steel is equal to T of steel upon J of steel. We have the dimensions, so we will have J and R also, and we have the T also. So by using that, we have just put the values for torque 500 into 10 to the power 3 Newton mm into 30 as the outer radius, by 32 60 raised to 4 is for steel, right? So you will get the shear stress 11.789 Newton per mm square. Similarly, find out for brass, you will get the value 7.758 Newton per mm square. Okay, the net angle of twist is same. Okay, so you can use the torque for brass, you can use torque for steel, you can take the dimension of steel or brass. Okay, so we will use to calculate angle of twist for steel. Okay, T of steel, TL by GJ of steel. Just put the value of torque, length of the steel rod, okay, material of the steel, and the polar moment of inertia of the steel. Just do it and take the calculation. Do the calculation. You will have the you will have the angle of twist 0.0187 radian. Okay, convert it in degree. Okay. Okay. So by that we'll finish our 5th unit, first chapter, torsion. Okay. If you have any questions, just call me or ask me through WhatsApp. Okay. Thank you very much.